I'm going to go through some experience and lessons learned that we've had in the UK, especially in Wolverhampton, where we've worked quite a lot. So the overview would be an introduction to myself, which Martin's just done a good one, so thank you very much for that, Martin. I think the background information of where archetypes come from, the practice I work for. Also, I think experience of talking at these things before is not a lot of people know about Passive House, so there probably some of you don't know, so I'll just give a basic rerun of that. Then talking about the two schools, Oak Meadow, and the lessons learned that has gone on to Wilkinson School, which is now on site, and then looking at the timber detailing and also lessons learned and how we work with Signum, a company, timber frame company from Ireland. So, as Martin said, I won't go through that again, but I've worked quite a lot of places over the world, most of those on eco buildings. Archetype is a company that's set up in South London 27 years ago. It's come out of the South Build movement from Walter Siegel, people who know him. It's a design-led practice, and we've got the environmental concerns at our heart. We also do a lot of client engagements. We've done the first BREEAM Excellent School, and we've completed 3 of the first 4 certified Passive House schools in the UK. We're now 40 people and split between 2 offices in London and Hereford. So a quick introduction to Archetype so you know where we're coming from, and then that leads to the timber frame building and the timber frame passive house that we talk about. So like I say, Archetype born out of 27 years ago, Walter Siegel movement. This is just some of the first projects. You can see the use of timber frame, natural light, natural materials, working with the user and occupier. Again, this was one of the projects that really put us on the map in terms of national press, the Horniman Museum in London. And again, it's natural materials, natural light. We're using natural ventilation strategies. And again, we helped build this, so we were part of the contractor process. So we actually helped build this building. I've put this one up just because I absolutely love this building, one of my favourite archetype buildings. But again, it's a natural product. I'm trying to get over here that we just deal with natural products. Timber frame, natural light, end occupancy, natural materials. This one was the Genesis project in Taunton. It's on a university campus. It's broken up into various pavilions, so one of them is straw bale, one of them's timber, one of them's earth, and one of them's eagle block. But again, the fundamentals are there, natural products, natural materials, good daylighting. This is where I work, in Hereford. This is an old barn that's been converted into our office. Obviously, the base of it is the original barn. The top of it is our standard timber frame. We were some of the first architects in the country to Styco joists and warm cell insulation, which is recycled paper insulation, and this is all part of this system here. The actual timber you see inside the building actually comes from the forest that you can see through the window, so all locally sourced materials as well. St Luke's School, the first BREEAM Excellent School in the UK, and again, the same principles are there from 27 years ago. Natural products, natural materials, good daylighting. So for those of you who don't know, I'm going to bore you now with Passive House, and those of you who do know, I'll probably bore you anyway. So Passive House introduction, it comes from sound scientific principles. As Thomas said, it's fabric-first approach. So we're going good buildings, we're just looking at the actual construction of the actual building itself, how it's orientated on the site. We're not worried about green bling or photovoltaics or things like that. We just want to get the building right. It achieves real energy standards and savings, and it's a sound way to reduce emissions and meet the new targets that everyone's been talking about this morning. And it's also tried and tested, relatively new in the UK and Ireland, but it's tried and tested everywhere else. There's about 15,000 Passive House certified buildings throughout the world, and most of those are in Germany and Austria. So what is Passive House? Well, we've covered it a little bit in the earlier speech, but it's a rigorous energy standard that achieves significant energy reductions. For instance, Oak Meadow Primary School has reported a 90% reduction in their gas bills from their previous schools. It's a rigorous comfort standard, which most people forget. So we're trying to reduce thermal bridging. There's no drafts in the building. It's better for the users, better for the occupiers. It's a rigorous quality assurance standard because of the certification process you have to go through. It was developed in Germany by Wolfgang Feist, and basically because buildings weren't performing as predicted, he felt we should be better at predicting how buildings perform. So the Institute was founded in 1996, and the certification documents usually go through those. So how do we achieve Passive House? Well, there's a series of technical standards in terms of U values, air tightness, eliminating thermal bridging. We use the PHPP, which is the Passive House Planning Package, and we use that as a design tool. That helps us orientate the building, design the form, design the fabric. We have to prove the thermal energies within 15 kilowatt hours. We also have to prove the primary energies within 120. And we have to undergo, as I say, rigorous certification. So just quickly, these are the principles. So U values, the letters in blue there, or the numbers in blue, are the UK standards of U values. The ones in red are what we're trying to achieve with Passive House. So you can see the insulation thickness has gone threefold, basically. Through the roof, we're about 400 mil thick of warm cell. The walls are 340 mil thick of warm cell insulation. Floors are 250, and all the windows, Thomas has said, is all triple glazed units. Air tightness, again, this is crucial to getting Passive House certification. So again, the number in blue is the UK standard. We're trying to get roughly 20 times better than that, so below 0.6. And most buildings in the UK struggle to hit 5. We're also thermal bridge free, so we're trying to reach good aesthetics, but we're also trying to do that without creating thermal bridges. So things like canopies at the front of schools are independently stand up on their own without actually penetrating the building fabric. In terms of ventilation, there's 2 modes in the schools. Winter, which is using MVHR, which is effectively drawing the cold air in from outside, drawing the hot, moist, warm air that's used in the building. The heat is transferred to that air and then provided basically fresh, heated air to the building. And in the summer, we're using natural ventilation, so through windows and also night ventilation. So very quickly, orientation is also very important. So we use the section of the building to control heat gains, to increase ventilation, but also draw natural light into the centre of the building. Some of these images just show how we achieve that. So Oak Meadow School, the first primary school that we did, and again, this was done cost neutral. So this school was done at cost neutral as part of the brief from Wolverhampton City Council. So the existing school is located on the large pitch. So we built the new school while the existing school was in use. It's on an east-west axis, south-facing, and we worked closely with the co-design and landscape architects to ensure we didn't shadow the building and overshade it. So the ground floor plan, you can see the south-facing classrooms there clustered around hub spaces, and the majority of those are south-facing. The north-facing elements are the auxiliary accommodations like kitchens, halls, etc., etc. And on the first floor, we've got voids within the first floor to allow natural ventilation to circulate around the building and also to get the natural light into the deep plan spaces. This school is a 2-form entry school, and it has a mast area which is just over on the left-hand side of the area, and that was for public use. So again, just a quick section to show how that building was finished from the preliminary section to how it actually looked at the end. And again, you can see the natural light and natural materials there. The front facade, we worked very hard on trying to get the windows to work correctly and the natural ventilation right. Some brise soleil on the south facade there. Again, another talk, but that was a nightmare for air tightness. And just some quick images internally just to show how these spaces looked. Obviously, this is prior to the client moving in. And some hub spaces there where children are working, etc. So Wilkinson School, this school is now on site as we speak, and is hopefully learning the lessons from Oak Meadow. So again, we're predominantly south-facing. The old school was demolished and actually arsoned and completely destroyed. So we're working around temporary accommodation. It's south-facing. Again, we work with the landscape architects on this. The ground floor plan, it's the same principles. We're getting south-facing classrooms, north-facing auxiliary spaces like kitchens, etc. But on the first floor, we're still using these voids to get the natural light and the ventilation system to work correctly. MVHR unit is now mounted on the first floor. But all these hark back to the days of 27 years ago. Compact form, form follows function, fabric first, very simple design. As you can see from extruded sections down the building, getting natural light into the building there. And these are just some planning drawings to show what the building looked like. So the timber detailing, this is just to show how we did it on Oak Meadow, and then I'll go into some of the quick lessons learnt. So this is a foundation detail. The blue is the structure, so we've got a structural slab, and then we've got the 140mm structural zone, which is timber. Then the air tightness layer on the inside, which is 18mm OSB. We've used tape such as Seagull or Intello, Proclima type products. And then basically we've wrapped the whole building up with insulation, so it's like, we called it the duvet layer. The structural engineers weren't happy with that and actually had a big argument that they didn't think they could basically land a whole building on a bit of polystyrene, but it turned out we can, so that was fine. And then a wind-tight layer on the outside, which is bit rock, which is again using Sega and Intello. And this just shows, we go through every detail and make sure it's thermal bridge free, so that is that detail modelled thermally. And then the first floor junction, you can see the red line there is the air tightness as the first floor plate comes into the external wall. The green zone is effectively a sacrificial layer that's got timber in it. The external, i.e. the beige zone, is a timber frame section that we envisage being sticos or TGIs, but actually working with Signum, they came up with an ingenious solution where OSB could be used and come out and then put softwood battens on the outside. It allowed them then to be more accurate in their build, but also the thermal bridging was reduced as well. So working with Signum, it's a good idea to work your subcontractors very closely. Again, the eaves detail, working up the building, red line's air tightness again, the green line is structure, but also on the roofs, like I say, we've got 400mm of warm cell insulation in there. The overhangs then are done from the ventilation zone and timbers in that, and those can extend out to 2.5 metres in some cases to give us some solar shading. So that was Oak Meadow. What lessons have we learned in terms of the next school, which is on site now? Well, we re-looked at all the details again. Although they worked and we achieved Passive House certification, we went through them all again. And we looked at how we could make them simpler. So we worked with Signum, with the timber framers from Ireland. We worked with structural engineers and came up with an even simpler first floor junction where the air tightness is OSB is continuous now. So it makes it a lot easier for them to check on site to make sure things are still working and still correct and make sure they do get below the 0.6 required. And then these are just saying some Signum details that we received on this project just to show how they've learnt from previous jobs. So now we're getting drawings in at an early stage indicating where they're going to have tapes, where they're going to have membranes. For instance, the one in the centre of the bottom is a plan detail showing an external wall and internal wall. They've left 100mm gap so they can go back and put the air tightness tape in afterwards. It's all lessons learned. Again, the air tightness detailing. On the left-hand side, there's the old school in Oak Meadow, and we had a problem with air tightness ripping when we put the flat roofs or the pitch roofs down on it. We've learnt the lesson from that now, and Signum now have come on site with air tightness already connected to the panels, but with a 9mm OSB layer over the top. So when the panels lay on top, we don't rip the air tightness membrane. Again, the panel there's a glulam beam coming into the external wall. It's pre-socked. It's got everything on it, Sega there. The whole thing comes in, we just flap the flaps back and put it around the OSB. So it works perfectly. The contractors learned, so the taping around the windows is a lot neater. They boast about how well their nursing corners are and things like that. They're proud to build it. Windows come to site with tape. They're pre-taped now. Everyone's learnt a lesson. We've learnt lessons. Actuators. We had a big problem with actuators at Oak Meadow. The actuators were in curtain walls. They moved with the opening sash. It meant the cables got caught. It was an absolute nightmare. Cost us a lot of money. But now at Wilkinson, the actuators are now within windows, so they don't move with the opening sash. We've reduced the number to below 20. It means the end user's got more control over their internal environment. But the most important thing was the collaboration between everyone. So this is just a meeting on site. It's got the contractor, it's got the design team, Passive House consultants, Signum timber frame, it's got the window people. Everyone comes around, everyone looks at every single detail. How can they make it better? We also had rigorous site inspections, thermography, make sure we had no thermal bridges. So in summary, we've hopefully achieved this with Signum and other subcontractors. We've used Passive House Planning Package from day one as a design tool. We're working with skilled experts. Simplicity in design, harking back to the days 27 years ago, fabric comes first. It's rigorous site inspection and working with your subcontractors the whole way through design, not just when it starts, but all the way through, right to the completion at the end. Learning lessons, taken on to the next project. And it's all based on the evidence that actually works. We know it worked at Oak Meadow, we've improved it, we've moved on. And just the little image at the bottom there just shows where we were probably 20 years ago. BMS was the big thing, everyone wanted to do it. It got so complicated, no one knew how to work a building, not even the people who designed it. So we're trying to get it back down to a simple form. You know, mechanically opened windows, we're trying to reduce, we're trying to get them manually open now. So the future for archetype, and hopefully people in this room, for subcontractors and window manufacturers and Signum, etc., we're moving on to passive house housing now. The directors of Archetype have set up their own development company, and we're building 150 houses in Herefordshire that are all passive house, trying to prove to the main developers in the UK that you can do it. You don't have to turn out the rubbish they turn out for 20, 30 years. We can actually do it for the same cost, and that's in planning at the moment. We're doing the Hereford Archive Centre. Again, it's going to be the first passive house archive building in the UK. The front bit there, the white box, is timber frame, lightweight. It's where the public can go. The back box is completely concrete. But again, it's all passive house. This sort of, people think you have to build passive house in a certain way. You can build passive house out of any material. It doesn't matter as long as you achieve the certification. First passive house church in the UK. Again, this is in planning, timber frame, in Sheffield. So again, we're trying to prove it doesn't have to be a typology of building as well. Also, the University of East Anglia, we're going back to the whole Genesis days, the one with the pavilion with the different timbers and straw bale, and we're doing the same thing here, but we're doing it to passive house. So we're using Brett Stackle and straw and reed, all locally sourced materials. We're also doing quite a lot of one-off houses in passive house, especially around Herefordshire, and the planners are actually now putting a condition in the planning condition report that has to be passive house. So we've sort of dug ourselves a hole because we have to achieve that now. But hopefully we will. Thank you very much for listening. Thank you.